Hello and welcome. Today we're going to talk about a couple theorems and do some really neat constructions. Our first theorem states that the perpendicular bisectors of the sides of a triangle are concurrent to a point that is equidistant from the vertices. Okay, concurrent. So concurrent, the definition for concurrent, when three or more lines intersect in one point. So that's concurrency. So this is called the point of concurrency. All right, and what we're going to do is we're going to draw a triangle. Okay, let me get a clean sheet. It's not folded up. We're going to go ahead and construct a triangle, and this point of concurrency does not have to happen within the triangle itself. So I'm going to draw an example where hopefully I'm just drawing a random triangle, okay? So hopefully this point of concurrency will not happen within the triangle. It can happen within the triangle or not. Point of concurrency. Okay, so what we do first is we need some perpendicular bisectors. Alright, so you'll remember from our previous lessons how to make a perpendicular bisector. Just open it at half, a little more than halfway, draw up, one down here. Guess I'm drawing them a little big there, my arcs, okay. I try to go a little fast, still be somewhat accurate. With this type of construction, accuracy is kind of key to get them all coming together at the same exact spot. Okay, let's try. Can't make any promises. We'll give it a good college try here. Alright, it's a little off. Let's keep going though. Okay. We got that one. Well, let's get this side here a nice bisector. Perpendicular bisector with this segment here. Leg of this triangle, okay. Okay. So, maybe I didn't draw my first one far enough up. Yeah, it looks like I didn't draw my first one far enough. Oh, maybe. Yep, let's see. So this is the bisector here. Oh, yeah. Okay, see, they're coming together right there. Now, we could actually stop right there. That's the point of concurrency. But we'll go ahead and do the third one just for fun because we love doing this stuff. Let me make my angle a little different here. Close it down a little bit so it doesn't run into that one. Here and here. Perpendicular bisector here. Here. Okay. So they should, all three of them meet right there. Let's see what happens. Hopefully I did okay. I'll get a better pencil. Might help. Pencil at the spare here, at the ready, okay? Yep. It's going to look pretty good. Alright. So we got our point of concurrency. Now, in this type of construction where these three lines come together, that's the point of concurrency. Now, in this type of construction, it's called the circumcenter. The circumcenter is associated with perpendicular bisectors. Okay, so you get used to the terminology. Alright, now what we do is we take the circumcenter and we put it on one of the vertices. And this circumcenter is going to be equidistant from all the vertices here. have a big enough piece of paper to make my entire circle. So, what am I going to do? Maybe I'll slip another piece of paper under here and pretend, hold it like this. And then, oh snap, there we go. Okay. Alright, there we go. Not too bad. Alright, so now I have my triangle in there. And my triangle is, and you can see it touches all the vertices here. Now, this point of, like I said, this circumcenter, the point of concurrence can happen within the triangle. It depends what the shape of the triangle is. Alright, so this, we say that the circle is circumscribed about the triangle. So the circle is circumscribed about the triangle. Okay, circumscribed about. That's what that means. All right. So there we go. That's one theorem we wanted to talk about. Here's our second theorem. All right. Our second theorem, it says the bisectors of the angles of a triangle are concurrent at a point equidistant from the sides. Equidistant from the sides. Okay. So here we go. What we're going to do is we're going to draw another triangle. And now we're going to talk about, let's just draw any triangle, make up one for ourselves. Alright. Any kind of triangle will do. There we go. Now we're talking about the angle, the bisectors of the angles. So we'll remember from our constructions, we're going to do some bisecting of angles here. So we have this angle here. I'm going to do the bisector of it. All right. I get my arc, and I'm not drawing the full arc, just so it doesn't get so messy. Now I'll go up here to this point here, draw my hash there. Now, connect that, then I have my perpendicular, I'm sorry, I have my angle bisector here. If I could draw this in pretty nice, I'll be in good shape. Now this point of concurrence on this has to happen, it has to happen within the circle, within the triangle rather. Okay, so here, put my hash here, measure this, and this will come up here, and over here. Okay, X marks the spot. Here we go. Keep moving. Angle bisector for this vertex. Let's see if I can get it pretty nice. Okay. Pretty nice. Okay. Now we could actually stop here, but just to prove the point, we'll go into the third vertex. We got this and this, so we'll move up here, and that went with this one. There's a lot of marks going on here. Okay, there's X marks the spot, so we'll go for this. And angle bisector. Okay, so there's the point of concurrence for this one, where the three meet. So this is called, now this one is called the incenter. The incenter. And the incenter has to do with angle bisectors. So now what we can do with the incenter is we can take and put our compass there and find the distance where it's gonna come to the side of one of these, the closest one, and we adjust our compass pretty nice, the best we can. And we're doing it real fast, so it's not going to look exactly perfect, but we can draw a circle around in here. Oops. Yeah, it's a little bit off. Maybe I could adjusted it a little further, but it's supposed to touch exactly. It's supposed to touch every side, and I just got in a bit of a rush here to illustrate. I'm going to run out of minutes on the video. So the end center here, it's gonna, these distances from the point where it touches it, from the point to here, the point on the segment here to here is going to be the same distance. It's like pretty much the radius of the circle from here to here. That will be a perpendicular. This line will be perpendicular. Here, I can go ahead and attempt to draw this very fast. So that will be perpendicular. That distance would be the same as distance from here, where the circle touches the. So that would be perpendicular. And where it touches here. So obviously these segments here will be congruent one to another. This will be congruent to this. Will be congruent to this. Okay? So there you have the end center. And we say that this circle, the circle is inscribed. The circle is inscribed in the triangle. The circle is inscribed in the triangle. Okay, so let's see. That covers these theorems. Go back to that first page here and talk a little bit. These perpendicular bisectors that we talked about. Find my page. Here we go. These perpendicular bisectors. Of course, what was happening here is we were making congruence. These segments, this was congruent to this, and this was congruent to this, and then when we cut it with this one, of course, it made this segment congruent with that segment. Okay, so you have the circumcenter, has to do with perpendicular bisectors. You have the end center, it has to do with angle bisectors. Yeah, I think I might have a note there about that. Inscribed, and well, I'm not putting my hands right on it. Anyway, there you go. You have the end center. It has to do with angle bisectors. The point of concurrence is called the end center when you're angle bisectors, and the circle is inscribed in the triangle. And then when it has to do with perpendicular bisectors, it's called the circumcenter. And then the circle is circumscribed about the triangle. All right, so hopefully that's helpful, and we'll look forward to seeing you on the next segment. Thank you for your time.